Hello out there in e-learning land. All right, let's get going a little bit more with our unit circle today. Um, we talked about setting up right triangles yesterday, using those special right triangles, using reference angles to draw those right triangles, and then finding our trig functions. I want to look for a couple of patterns today. I want to show you guys a couple more ways to think about it, but specifically talking about patterns of negative and positive trig values. So I set this up kind of like if we would do it in class and get you guys thinking about your own. So I'm going to step through these questions and give you a little processing time and think about what I'm trying to get at here and what that ultimate conclusion is. All right, so first we're going to draw each 45-degree reference angle and set up the right triangle. So this is just like what we were doing yesterday, right? If I gave you guys an angle, you were drawing that. In this case, I have a 45-degree angle right here in quadrant 1. So there's my 45, 45, 90. I have a 45-degree angle here in quadrant 2. There's my 45, 45, 90. And notice, if you think about what angle that actually is, that angle is 135 degrees. All right? But again, this is all in terms of reference angles and thinking about each of these angles and what quadrant they're in, but using the reference angle to make the special right triangle. Okay, so this angle would actually be 225, but here again, we're in that third quadrant. In that fourth quadrant, we'd be here, and there's our 45, 45, 90. Now, when I was doing this yesterday, I showed you guys, or told you guys to think about this as quadrants, okay? And if we graph a point in a quadrant, if we go left on the x-coordinate, then that's a negative. If we go down on the y-coordinate, then that's negative, okay? So we did this, right? Reference angle, label the lengths of each side. All right, so now as I label the lengths of each side, we're going to do, instead of a unit circle, we're going to do a circle with a radius of 2. Okay, and if you guys watched that video from Monday, or if you look at other people's notes, or go on Khan Academy, you're going to see a lot of stuff with the unit circles. And I prefer to use this radius of 2 because then I can go with these special right triangle side lengths that we already know. All right, so we know all those hypotenuse, the radius is all 2. Now, as we fill this in the first quadrant, we know that we're going right, and this is root 2, right? Positive root 2. We know that we're going up, and that's positive root 2. So that means all the trig functions are going to be positive in the first quadrant. All right? Now, when we go into the second quadrant, we're going left. So that means that this x quadrant coordinate, or this moving on the x-axis, is negative root 2. Moving up here, we're going up, is positive root 2. When I go into the third quadrant, I'm going negative root 2, and then I'm going down. And again, that's negative root 2. In the fourth quadrant, we go right, positive root 2, and we go down, negative root 2. All right, so look at these signs now. And really, here's the question. What does this tell us about the signs of each trig function in each quadrant? So as we look at it, in quadrant 1, everything's positive. In quadrant 2, as I do a trig function, let's take a look at it. Let's do sine of 45, or in this case, it's really 135, is going to be opposite over hypotenuse, root 2 over 2. And that's positive. What if we do cosine? Cosine 135 is adjacent. And here, since the adjacent is the x value, it's negative root 2 over hypotenuse. And that cosine is negative. If we do tangent, tangent is opposite, root 2 over adjacent, negative root 2. And that gives us, again, a negative tangent. So that means in quadrant 2, okay, the only one that is positive, sine positive in quadrant 2. And you guys can work your way around and figure out this pattern the same way. So let's see. They're all positive in quadrant 1. Sine is positive in quadrant 2, and the cosine and tangent. And of course, those reciprocal functions are going to have the same sign values, positive or negative. When I go to quadrant 3, notice the x is negative, the y is negative. And that gives me tangent is going to be opposite, which is negative 2 over negative root 2 over negative root 2, which ends up being positive. So sine is positive in quadrant 1 and 2. Tan is positive in quadrant 3. And I bet you guys can guess then which one would be positive in quadrant 4. If we do cosine, that's going to take this positive x value over hypotenuse. So cosine in quadrant 4 is going to be positive root 2 over 2, and that's where cosine is positive. Cos positive in quad 4. Okay, now there's a couple different acronyms and ways to remember this. The way I remember from high school is my teacher said, starting quadrant 1, that if you remember your signs, then you have a smart trig class. And a smart trig class stands for all positive. Let's get rid of that. All positive, sine is positive, tangent is positive, cosine is positive. All right, so that's a little pattern that can help you guys. But if you're doing your special right triangles and labeling where they're negative, you'll always get those signs correct anyway. But that's a quick check for you. All right. Next, we're going to talk about quadrantal angles. All right. So quadrantal angles are going to be the angles on the axis. So angles with terminal ray on the x or y axis. We call them quadrantal because they make the quadrants, or they separate the quadrants. So there they are. All right. So there's our quadrants. Draw a 45-degree angle. Okay, we're going to kind of look for a pattern here again. Now, the quadrantal angles we cannot use special right triangles for because we can't take sine of 90 because the opposite of 90 is the same as the hypotenuse. Okay, so we're going to kind of use this idea again, draw a 45-degree angle and set up the right triangle. So if I draw this 45-degree angle, set up my right triangle, I'm going to use my hypotenuse of 2 again, and I know that this side is root 2 and this side is root 2. Okay, now think about this as each point that I've drawn in the circle is a coordinate. So to get to this point, I have to do, sorry, that's not negative. I have to go to the right root 2 and up root 2. Okay. When I get here, I'm going left or right 0, and the radius is 2, so it's 0, 2. When I get here, right, this is going to be then I went left root 2, so negative root 2, up root 2. When I get here, this is going to be negative 2, 0. When I get here, this is going to be negative root 2, negative root 2. All right, let's fix that. It looks terrible. There we go. When I get here, I'm going 0 left or right, and I'm going down 2. When I get here, I'm going positive root 2 and down root 2. Now, I don't use these coordinates a lot, but I want to use it to help you guys see the pattern. So watch what we do now. I'm just going to focus on this right triangle that I drew. When I look at sine of theta, and in this case, we're going to look at 45. Okay, sine of 45 is going to be opposite over hypotenuse. And as you guys look at that, notice that opposite is always going to be your y coordinates. And hypotenuse we know that cosine and sine are always over the hypotenuse. So cosine, look at it now. Cosine of 45 is going to be adjacent over hypotenuse. So adjacent is going to be your x-coordinates over your hypotenuse. And tangent is going to be opposite, which is root 2, over adjacent. And that's going to be your y-coordinates over your x-coordinates. So think now, I wrote, how can we apply the same idea to quadrantal angles? Because we can't draw these triangles and do them. And this is the idea, okay? So as you guys think about your quadrantal angles, think about these coordinates here, okay? So sine of theta equals y over hypotenuse, okay? Cosine theta equals your x-coordinates over your hypotenuse, and tan theta equals your y-coordinates over your x-coordinates, because those are the sides of those triangles. X-coordinate, y-coordinate. Hypotenuse is 2. Again, I'm using a circle with radius 2, so we have that consistency. You're going to see this a lot where people use a unit circle, so the radius is 1, and then it makes it x or y over 1 for our sine and cosine. All right? Feel free to search this on Khan Academy. If you like the unit circle better, go with that. Okay? Otherwise, pause this, see if this makes sense, try it out. I'm going to do a few problems for you guys now. All right, and you can see how this works. All right, so you can see all of these are quadrantal angles, which is kind of the first thing you need to make sure you're good with today is, again, do I know where this is? So as I look at 2 pi, just like we did yesterday, we're going to graph where that angle is. 2 pi starts here and goes all the way around and ends up right here. All right, so now as we do this, you can think about this as drawing now your unit circle. So if I draw my unit circle, or in this case, my circle with a radius of 2, the coordinates of this point are 2, 0. Zoom in a little bit. All right, so the coordinates here are 2, 0. So remember what we figured out on the first page of our notes here is that cosine of theta equals our x-coordinates, because x is the adjacent side, over our hypotenuse. So in this case, cosine theta, or cosine of 2 pi, equals x is 2 over our hypotenuse, our radius, and that equals 1. Okay? Let's do it again. 270. You guys just want to start by drawing a circle. If that's better, 270, if we draw our circle in here, is going to be right here as we go around. So if we write those coordinates down, our x-coordinate is 0, our y-coordinate is -2. Okay, and now we want sine. So sine of 270 equals, now we use our y-coordinate over our hypotenuse, okay, or our radius, and sine of 270 equals, our y-coordinate is -2, and our hypotenuse, our radius, is 2. So there, sine of 270 equals -1. All right. I'm going to keep cranking through. Again, this is really conceptual. There's not a ton of work. It's just a lot of thinking behind it. But I'm showing you guys this so you can make sure you can figure these out without a calculator. You need to be able to do that for pre-calc. You'll need to be able to do that for calculus as well. All right, pi over 2 is going to put us right here is 90 degrees. Our coordinates at that point would be 0, 2. Or again, if you wanted to use a unit circle, you could put 1 there if that's helpful, more helpful for you guys to see. All right, so as we do that then, tan of pi over 2 equals, and that's going to give us, then we want our tangent is going to be opposite, which is y over x. If you forget, remember sine is y, cosine is x, right? Opposite, adjacent. Okay, sine is opposite over hypotenuse, tangent, or cosine is adjacent. So our y coordinates, tan of pi over 2, equals our y-coordinate, which is 2, over our x-coordinate, which is 0. And what's going to happen if we divide by 0? Put it in a calculator if you want to see. We just talked about this in our last unit as well. We get an undefined value. So tangent of pi over 2 is undefined because we can't divide by 0. All right. I'm hoping you guys are kind of starting to get the hang of it here. You're going to practice some more on your own. Let's do a few more together. Secant is our reciprocal function. All this is going to do is switch it around. All right. So if you guys remember, let's get our angle on here, and then we'll talk about, okay, pi over 2, again, is right here up on top. So if you want to draw your circle, you can. 0, 2, okay, or you can put 0, 1 again, whatever you want to do. All right, and secant is the reciprocal of cosine. So that means secant equals, right, reciprocal of cosine, which is hypotenuse over adjacent. Okay, and in this case, remember that it is 2 over our x-coordinates. And our x-coordinate here is 0, so that means that 2 over 0 is undefined again. And that's going to happen when we get that 0 in the denominator. All right, so there's a few more here. Let's see if any of these look different. They're all really similar. 720, remember, we can have coterminal angles. 720 is going to loop around. There's 360. It's going to loop around again. There's 720 is going to end up right here. So really, again, when you guys do that unit circle, we just care about the coordinates of that point. And that's going to be at 2, 0. And we want sine. So sine of 720. Sine is going to be our y-coordinates over our hypotenuse, which is 2 in this case. So it's going to be 0 over 2 or 0. All right, I might as well get these other answers up here for you guys now so you can get going on your homework and practice these out. So 180 is going to be right here. The coordinates are going to be -2, 0. Tan is going to be, remember, is going to be y over x. Opposite over adjacent side is the y-coordinate over the x-coordinate. And that's going to give us 0 over -2. So you guys are going to notice here that you're going to get a lot of zeros and undefines and ones. That's what you're going to be seeing a lot of here. All right, let's do cotan. Cotan, remember, is the reciprocal of tangent. So it's going to be x over y in this case instead of y over x. Pi is going to be the same as 180 is going to be right there, -2 over 0. Okay, our x-coordinate, so cotan pi equals our x-coordinate, -2 over 0, and that's going to be undefined as well. All right, so and last one here, -3 pi over 2 means we're going to go down. So -pi over, or 2 pi over 2, -3 pi over 2 is going to put me right here, up there, and our coordinates are going to be 0, 2, and cosine is going to be our x-coordinates over 2 in this case, because that's our hypotenuse, our radius, and that's going to be 0 over 2, which is just 0. All right, so there you go. As you guys are doing the homework tonight, you're going to see that these are mixed in with the problems, with the angles from yesterday where you're doing your special right triangles. Look for these patterns today. Again, this is confusing at first, but once you guys practice and get your head around it and just think about these kind of new formulas, thinking about your coordinates, tan is y over x, right? Sine is y over hypotenuse, cosine is x over hypotenuse. You can figure these out really quickly just by putting it on your coordinate plane and writing out that point, okay? All right, as always, please email me if you have questions. I am here to help. If you guys want to do a Google Meet this week, please let me know. Be happy to host a Google Meet. If you want to get together some friends and do a group Google Meet, if you guys are working together, let me know that. We can do a special group Google Meet. Otherwise, I can also schedule one and leave it open for everybody. Just let me know, guys. Keep up the awesome work. I will talk to you soon.